Hello, in this video we are going to go over the solution of the problem 102, binary tree level order traversal, and we are going to use BFS. Imagine that we are given a tree like this one, and what we are going to do, we are going to return a list that in this list, for example, on the right side you see the result. Each element is gonna be the nodes in that level. For example, for the first level I have node 2, for the second level I have node 1 and 6, for the third level I have 4 and 7, and for the last level I have 5 and 3. Okay, let's start writing the code. As we are going to use BFS, we are going to import DQ first. So we say from collections import DQ. Okay, the first thing that we are gonna do is to create an empty queue. We say queue is DQ. Also, I'm going to return a list at the end, so I'm gonna call that result an empty list. And if the root given to us is just empty, we can just return the empty list result. So we say if not root, return result. Okay, now we have h equals 0, and that is going to be our height. So at this level is 0, h is 1, h is 2, h is 3. Also, I'm going to add root to my queue. I say queue dot append root. Now I say while queue, so I'm gonna create an empty list for that specific search. So I'm gonna say result dot append just an empty list. Then I need to know what is the length of that level that I'm gonna visit. So I say level length equals length of queue. Okay, now we go for a for loop to search around it and say for I in range of level of length, we say node equals queue dot pop left. Then I need to add that value of the node to the result. I say result h dot append node dot 1. The next thing that we are going to do is to update the queue. We say if node dot left exists, we say queue dot append node dot left. Similar for right, we say if node dot right queue dot append node dot right. And then I need to go for the next height. You remember I had h equals 0 here. Now I have to go one step forward. So I say h plus equals 1. And now I'm going to return result. Okay. Okay, let's run it and also print the node value. If I do that, let's see what we are doing. First I was at node 2, and then I went to the next level, h equals 1. I had node 1 and 6, the height 2. I had these two nodes, 4 and 7, and at the last level I had 5 and 3. Okay, now let's print the queue, and we say we get a queue like this at the beginning because I added root here, and queue is this one. So it has only one element, that's the node root. Then when I go forward, for the next one, I have these 1 and 6 as the nodes added to the queue. So my queue is actually has two nodes. That's the node 1 and this is the second one. And then we go forward again. I update the queue, and at the end, queue is empty because we visited all of the nodes. So that is the reason while loop is stopped, because there is nothing inside the queue anymore. The time complexity of this problem is order of n because we are visiting each node only once. And the space complexity is also order of n. We created this list here, results, and we need n spots for that. As a result, our space complexity is also order of n. Okay, this is the solution of the problem 102, and thank you again for watching this video.